So for example, number one, so just to remind you guys, on our last section, we dealt with really big numbers. The reason this is called scientific notation is because in science, we do really big numbers, right? Like, what is the distance between Earth and the moon? It's a really big distance. It's a really big number. And so we can condense it so that it's scientific notation a little easier to work with mathematically. Also in science, we deal with really small numbers, like what's the length of an electron? That's a really tiny, tiny, tiny decimal. So we're going to learn how to deal with the tiny, tiny numbers and do scientific notation. No, stop. Look up here. The average size of an atom is point, a lot of zeros, 3 centimeters across. Write the average size of an atom in scientific notation. So basically what we're going to do is we still want something that looks like this: A decimal point, B, C, whatever, times 10 raised to some power. Okay. Now, on the previous examples, when we were doing big numbers, when we were doing really big numbers, really big measurements, we had positive powers of 10. When you do really big numbers, it's always positive. When you have really tiny numbers, decimals, like this one, see all these decimals? It's still the same, but we're going to have a negative number. And that's based on the number of spaces that you move the decimal, okay? So if I look at this, and I want you to write this in your books, I go 1, 2, 3, 4, 5, 6, 7, 8. So what I want to do is I want to make it look like 3.0, okay? Now, in order to do that, I had to move my decimal place 8 spaces. So because I move my decimal 8 spaces, it becomes 3 times 10. But because it's a decimal, because the number is a decimal, it's a really small number, like in terms of measuring things, right? It's 3 times 10 to the negative 8. That's the only difference, okay? Thumbs up, thumbs down if that makes sense. Thumbs up, okay? If your thumbs down, that's okay. We'll keep going over it. All right, so I'm going to give you guys like maybe 15 seconds. Let me read the question, and I want you to try to answer it on your own, then we'll go over it together. When you write a number that is less than 1 in scientific notation, how does the power of 10 differ when you write a number greater than 1? So really, let me translate that. When they say less than 1, they're saying, what's the difference between a decimal, and that's the language you guys would use, right? What's the difference between a decimal, or you could think of it as a fraction, less than 1, as opposed to a number greater than 1? So greater than 1, you could just, think in your head, right? Like 2, 3, 4, 5,000, 5 million, 10 billion. What's the difference in the scientific notation? Are you trying to answer the question? Just wait a second. I'll call on you in about 10 seconds. Let's everybody have just a couple seconds to think about that. So what's the difference when we convert things to scientific notation for a decimal or fraction compared to like a really big number, like 5 billion? All right, what did you think it was? Yeah. So for decimals, the exponent is negative. Okay, that's it. We count how many spaces we have to move that decimal point, and instead of making it 10 to the positive power, the number of spaces, we make it 10 to the negative power. Okay, any questions on that particular example?